Welcome everyone to our Wednesday webinar. My name is Michael Wimberly and I will be presenting Resolving Creo Model Regeneration Issues and Best Practices. So the overall agenda for this webinar, of course, is to go through and just do a general introduction about boundary systems and myself, do an overview of the topic, and of course, do a demonstration of some of the items that are covered in the topic overview, and then have a Q&A at the end of it. If you do have questions, you can post those in the question area inside of the webinar dialog box, and I can address them. I try to address them at the end, but if there's one that are too specific area that I'm covering, I try to hit that at that point in time if I can. All right. So just an overview once again of myself. My name is Michael Wimberly. I am a solutions architect here at Boundary Systems. I've been working with PTC products now for over 25 years and have been a certified trainer for over 20 of those years. I am a certified trainer in Creo applications as well as Windchill, and I am also a Windchill certified implementation specialist. As for Boundary Systems is headquartered in Cleveland, Ohio, but we have offices all across the world. Excuse me. I personally actually live in Cincinnati, but we have partners not just in the US, we also have them in Canada. You can see on the map, we have them in Europe area, we have them in South Africa, as well as over in the Middle East, or in the South Asian area as well. Now, as for us, excuse me, we are a technology leader. We partner with PTC, Solid Thinking, eTraj, Autodesk, and other technical companies to bring you the best overall product. We have been the 16th fastest growing company, private growing company in the Cleveland area, and we are a part of PDSVISION. That actually allows us to be a more global company than we were before. So a lot of our new locations are in the Europe area, which is based on our partnership with PDSVISION Group. Our overall capabilities are product lifecycle management, of course, data management, CAD design and consulting, simulation, and even product development. Now, our overall mission as a company is to have the most technical expertise on PCC products in the world. We have a lot of individuals that have a lot of expertise in a lot of different areas. That's what makes us one of the global leaders in technical expertise. By having that knowledge, it allows us to understand the needs of our customers. So we'll get you partnered up with our best subject matter expert in that area that you have questions about, and understand what it is that you are looking to do. And by doing that, when we do recommend information or products for you to use, we guarantee the success of that solution, because once again, we've worked with you, our expert has worked with the actual products themselves, and we're saying that what we're giving you is going to benefit you overall, because what we're trying to do is decrease costs, decrease time to market, and of course increase the overall quality of your product. Now, with that, once again, we do offer the overall suite of PCC products, but we also have other partnerships, and these are just a few of those: Tacton, Modex, Xformation, eTraj, ITI, ZWCAD, Keyshot, Sigmaxim, and Cimerix. With those, they deal with, some of them deal with some of the FEA information, some of them deal with licensing information, 2D CAD, also creating custom applications. So all those things, or you can find more information on those on our website at boundarysys.com, or if you do have or want information, you can also always email me and I can get you connected to the right individuals. All right, so if you do want to get in touch with me, you can reach me directly through my email at mwimberly@boundarysys.com. If you want to get in touch with our sales department directly, you can go or email sales@boundarysys.com. But of course, you can always reach us directly in our website at boundarysys.com, or this webinar that we're doing here and all the webinars that we've done in the past are on our YouTube channel. So just go to YouTube, search for Boundary Systems. You'll find our page, subscribe to it. That way you'll get notified anytime we do post new content. And of course, you can review any of the existing content that we have on our YouTube page. All right, so now going into the actual topic itself, which is the resolving Creo regeneration issues. Now, one of the issues that companies or the individuals have may be going in and having to regenerate the model multiple times. So when you go through and create your geometry, maybe you've gone through and written some relations, you have some other dependencies, external, but in order to get your geometry to update properly, you have to go through and regenerate your model multiple times. Well, once again, with that, relations relations calculate before the geometry and may become outdated before the geometry updates. So once again, depending on the order that we've written our relations, we may be updating some geometry before or after a relation is actually looked at the value of that geometry. Now, with that, some of the ways to go through and resolve that is inside of the relation dialog box, there is an option for sort relations. What that does, it goes through and actually looks at your relations and validates that anything that you're setting an object equal to is actually changing or updating properly before that secondary value is now set to that first value. And I'll show that actually inside of a demonstration that I'm going to do. Another one is going in and have a relation feature. Inside of there, you can go through and specify the order of regeneration inside of there as well. The other thing is, of course, assemblies. With assemblies, as I mentioned before, those could go through and get out of sync because of the different relationships that you may have to different features. So depending on how you may have referenced one feature to another feature, or once again, we get into relations where we're going in and setting one value from one component equal to another value in another component, then those may go in and regenerate out of sync as well. One of the other issues that we talk about or that we have is slow regeneration of patterns. So they may regenerate slowly. Now, by default inside of Creo, it uses technically the slowest option to regenerate your pattern, but it has the most flexibility. And that pattern type is called a general pattern. There are two additional options, which are variable pattern and identical pattern for our pattern features that we can also use. I'll cover some of that as well. Of course, with those, we can also look at simplified reps. You have the ability to go through and replace a pattern with basically a point. So instead of actually showing every instance of that pattern, we can just go in and represent it with a point that simply shows where that instance is going to be. You also can have predefined reps using a graphics and geometry rep. So instead of going in and actually regenerating the whole model, it's just going in and basically showing a representation of it based on the last save that you have. And then of course, we also have the ability to go through and use part simplified representations. So if we are looking at working inside of an assembly, when you go in and create your simplified reps in the assemblies, one of the things that you can do is also substitute a fully modeled part with a simplified version of that. So maybe you don't need the holes, or whatever that pattern may be. We can go in and remove that from the simplified rep and still have the overall geometry represented inside of the model. And then we also will talk about circular references. Anybody that's been on Creo for any point of time, or I should say go back to the name of Pro Engineer, I'm sure at some point in time we've run into circular references. So what we'll go through and talk about is what they are, which is simply a feature referencing another feature that references another feature that actually goes back and references the original feature that started it all. So that's the kind of the loop that you can go in and create. It actually creates a CRC file, which is basically a circular reference file. and it'll go through and show that. And you can also go in and use a reference viewer that shows you how these different features are referenced. Uh, and then, of course, to go in and limit some of that, especially when we're dealing with the assembly level, we can go through and control it by going in and controlling external references to go in and limit what can be referenced when we're activating the part at the assembly level. So we can go through and set it up so it does not allow any references outside of the part that you have active at the assembly level. So I can't reference part B if I have part A active. So it kind of helps prevent some of those. We also look at analysis features. Sometimes we have analysis features in our model tree because we want to go in and make sure that certain values continue to be updated. So with that, an example being a mass properties. Now with the mass properties, that is in your model, and it can actually slow down your regeneration, because when it regenerates, if you're looking at the assembly, it could go through and run that regeneration for every part that gets regenerated in the model. So as soon as you update a part, it runs this mass properties calculation, regenerates the next part, runs a mass property calculation. So instead of doing it at the very end, it goes in and does it as parts are being regenerated. One of the ways to go in and do that or avoid that is to go through and, of course, suppress it and just bring it back when you need it. Or you can change the regeneration option of that feature, where instead of doing always, you can do it read only, or when you're doing a specific design study. So when you're in that actual function, you can go in and do that as well. The next one is simply talk about improving regeneration speed with Creo efficiency. So this is one of the areas that you can also use this when we talked previously about the external references. We talk about top-down design methodology. Now, I'm pretty sure we have webinars on this as well. So definitely go to our YouTube page and find that webinar for top-down design. We may have a couple on that, dealing with different aspects of it. But it is definitely a useful function if you're not currently using it. But it's basically, I'm sure you may have heard the terminology of skeleton models. That's what this is basically referring to, is basically creating a skeleton, or basically a part that is no more than datum features and surfaces that you use as references for your different models in the assembly, instead of referencing the secondary models directly. So with that, we can copy geometry from the different parts into the skeleton, and now everything is simply tied to one part, but the skeleton uses the geometry for everything else. We can also go through and use a Pro notebook. That is also very useful. Inside of there, you can go through and use parameters inside of there to go in and drive different relations inside of your models. So if you are going in and maybe you have an assembly that has quite a bit of flexibility inside of it, one of the things that you can do is have the values or parameters that are driving those different relations in the notebook. And now we can go into that notebook and go in and update the values inside of there to update the values inside the assembly. And with that notebook, we can have several, and you're simply declaring the assembly to the appropriate notebook, and it updates the values based on those information or that information. So, and once again, I'm pretty sure we have an actual webinar on that as well. And the last thing is just simply going in and talks about improving part regeneration and time. One of the things is round features should be basically put towards the end of the model. So with that, develop your model and then start putting in your rounds towards the end of the model. You should not have round geometry too early in your model. One of the ways to actually monitor that is there's actually a check inside of model check that actually deals with early round creation. So you can go through and specify what percentage. So I don't want any rounds within the first 50% of my model. So you can go through and actually kind of set that up as well. Avoid using auto round on complex models. Auto round is an awesome function, but when you get into a lot of complex geometry, it can go through and slow you down. Now, those of you that aren't familiar with auto round, you can basically go through and round all the edges of your model and specify for convex rounds, it's a certain value, for concave rounds, it's a certain value. Now, I do think it is useful for things like casting that have standard rounds. Everything is this value, unless otherwise specified. If you're using that function for a casting, then what you would do first is create all of your quote unquote otherwise specified rounds. So anything that is not of the standard size, you would create those first and then use the auto round function. It will round all the other edges that don't have specific rounds on them already. Also, avoid using edge rounds if possible. If you can use surface to surface rounds, that makes it better. Another option for that, instead of using just direct edge rounds, is also using an intent edge. That actually also avoids some regeneration issues that you may have, because it's looking at the edges, but it's looking more at the geometry that the edges are controlled by. So if you change, if you have a round on the edge of a circle, and then you change that circle geometry to a hex, with the intent edge, it will automatically update that geometry or that round to be attached to the edges of the hex versus the actual edge of the circle. Also, this is very important. The next two actually, avoid round children. So try not to have, I should say try, I won't say try not, don't have rounds that have child features unless it's like a chamfer or another round or something like that. But no real geometry should be referenced to an edge of a round, because now it's driven by the size of that round, which is more than likely the tangent edge of that round. So when that round changes, your geometry will shift. Also, avoid meaningless features, basically features that don't do anything to your model, such as cuts that don't intersect the model. And it tells you down there in your message window that you have features that don't intersect the model. Find out what they are, get rid of them, because once again, it's not doing you any good. Also, extrudes that fill pre-existing holes or cuts. Yeah, it's not easy to see sometimes on the model, but a lot of times, I won't say a lot of times, that is done. It's been done in the past. I know that, but I know you guys are better than that. So we're not filling in those things. If we don't want them, we go through and delete them. I'll also say with that, there's also an option for that in model check that will actually go in and check for that function if somebody has actually filled in a hole or a cut with actual geometry. And datum features without children, why have them in there? Yeah, datum features don't take a lot to regenerate, but it does actually expand the length of your model tree. So you have features in there that you don't need anymore. So get rid of them if you don't need them. Then you can also go through and manipulate the accuracy. With the accuracy, there is a default value, but understand if you increase, or I should say decrease, the accuracy, then it will go in and take a little bit longer to regenerate your model. So if you go through and now make that accuracy basically a larger number, the regeneration speed will be a little bit better. But when we talk about at the bottom, the last item talks about avoid relative accuracy when designing, when the design requires small features on larger parts. Basically, that's where a lot of our geom checks come in. So geometry check come in when you have something that's very large and it creates a small sliver somewhere, and it's not sure if you actually want what it's actually giving you. Sometimes by changing your accuracy, it will remove that geom check. But once again, by changing the accuracy to making it more accurate, then it will increase the amount of time of regeneration. So keep in mind of that as well. If you can leave it alone, leave it alone. If you're okay with a couple of geom checks, deal with those. Otherwise, once again, you're going to increase the regeneration speed of your model. All right, now at this point, I will go into demonstration. Now, the first thing that I'm actually going to go into is just the regeneration mode. So, and if you guys have taken any of the PTC classes in the past, um, you will actually see, or some of these will be familiar with you, but I'm just using it for the overall environment. So here we have a simple part, and here we have a simple chamfer on the end of it. Right now, it is set at 0.65. I am going to go in and increase that. Of course, it's something that is ridiculous, which is 0.2. Now, when that happens, there are several items. When you have a regeneration failure, there are several areas for you to recognize that you have a regeneration failure. If it can, it will show you on the screen, like you see here. It goes in and shows red and purple. The red is the actual feature that has failed. The purple is a child of the feature that has failed. You will also see down in the message area, you will see this little red flag that lets you know you have a regeneration failure. And of course, in the model tree, you'll see that your overall name of the part is in red. And then of course, the feature that has failed is red with a little exclamation point next to it. And then of course, its child is also in red. Now, to go in and begin to investigate this, you can come down here at the bottom to the notification area and select it, and it says one feature, one regeneration failure. Select that. And now inside of here, we can go through and actually see what's going on. When you go to select on the feature, it simply tells us the geometry, regeneration, failed regeneration, feature geometry, not up to date. So we can go in here. There's multiple tools that can be used. So we have a global reference viewer. We have our edit references, and then of course we have our edit definition. So we can use any of these to go through and update. We also simply have a regeneration manager. So if you think it's just simply a regeneration issue, maybe around, I've seen that before, maybe you have as well, where it's going in and it's trying to calculate the rounds and the initial regeneration didn't calculate things properly, or maybe it needs a second regeneration, which is what we were just talking about a moment ago. We can just simply go in and tell it to regenerate it again. And then over here, we can also go in, if we have a larger model tree, we can tell it to find that component in, or that feature in the model tree. And of course, we have feature information, which will tell us just overall feature. And then of course, just simply the display of the information here. So, all right, so if we come over here and just do our reference viewer, for what we're doing here, there's not much, for us to go in and reference, because the references that it uses are there. So the issue for this one isn't what it's referencing. The issue is actually the feature itself. So, and I'll come back into this one in a moment. So the actual issue is this feature. So once again, we can go into our notification center, or we can go directly into the feature, edit definition on that. And once again, we can see that it has failed. The value is not valid. Change the value. It can go through an update, and then that geometry is up to date. So there's a lot of tools that are available inside of here. Now, the thing, as you can see with Creo, is that it will allow you to have an actual failed feature in your model tree and continue to model. And older versions prior to Creo, that was not possible. If you had a regeneration failure, it will bring up what we call the resolve mode. And anybody that's used Creo back in the Pro-E days knows that it will bring up what we used to call that little gray box of death, which basically said, okay, I have a regeneration failure. Here's the regeneration. The model tree was clipped back to where that feature was. Your model only showed up to that feature, and you couldn't go past it until you resolve that issue. So for here, we can go in and still have regeneration errors and still work on our model. I think in the config options, I don't know if it's still available in 7 or 8, but I know in previous versions of Creo, you could actually turn that on. So if you did want to torture some people, you can still turn on the resolve mode and work through that to force the regeneration of, or first force the fixing of the models. Also, I'll go into model check again. If you are using wind chill, you can go through and set that up as a gatekeeper that will not allow individuals to check in files that have basically failed features. So that will be something that will be can be set up where it will show up as an error in your model during model check. And once again, if it has an error, it won't allow you to check those files in. So once again, pretty simple here. I said it's just the environment that you will go through and work inside of. One of the other items that we can also work with, and this one will go into the reference view a little bit more. I'm going to go in and edit this geometry, edit it sketch. Now, when you're in Sketcher, sometimes it will actually go through and let you know that what you're getting ready to do is going to break a relationship between the feature that you're working on and some other subsequent feature. So it's letting you know that what I have is actually referenced by something else. And it's asking you, do you want to continue? I'm going to say yes. And then I'm going to go ahead and add my additional feature, which is simply just a little arc. And I'm going to make that there. Great. Finish. Now you can see that it completed what I did. So the geometry I just created is valid, but I still have a regeneration failure in my model. Same thing, I have my notification come up. I can see in the model tree that I have, the side round, and then there's 2 additional children round that are failing. And of course, as I mentioned before, the actual overall name of the model is also failing. Now for this one, I'm going to go into the notification center and look at the geometry like so. Once again, pull this over so we can actually view it. Now for this one, I will go into my reference viewer. Now inside of here, you can see that on the right side, there are the children of that round. Here's the actual round itself. And then on the left side are the parents. We can see that it's using this protrusion, that protrusion, and then it's using the base protrusion as well. If I expand the references used in the base protrusion, I can see that it's showing me this surface here, this surface here, that surface over there, and now it's showing me this surface here. Now that is a surface that it's missing. Now that surface is missing simply because we deleted the edge that represented that surface. Now to fully understand what is going on here, we can also go in and figure out what this feature is. So if I come over and I'm just right clicking on this feature and I want feature information for it, it brings up a separate window. And the reason that's failing is because the feature is actually a full round. And that full round is using surfaces. So what's happening is the round that was using this surface is actually failing because that surface is no longer there. So I'll go ahead and close this out. And I can do it multiple ways. Once again, I can come over here, select on it and do edit definition. Or if I was still inside of here, I can come over, select it and do edit definition on that as well. Either one will bring me into my edit definition dialog box or my dialog box, or sorry, ribbon for the actual feature. And then like everything else in red, it will show me what is actually my issue by going in and having the sets tab highlighted in red. It'll come over here and show me which set is the issue, which is set 2. And then even down in the references area, it shows me that the driving surface with this red dot is the item that is missing. As you can see, once again, it's still highlighted on the screen where that surface used to be. And now I need that surface to be here. Once I do that, it now goes in and replaces that feature. And now it can go through and regenerate that properly. And all the subsequent features will also regenerate at that point. So very simple. It's just, once again, getting familiar with some of the tools inside of Windchill. I'm sorry, not wind chill, sorry, wind chill on the brain, inside of Creo, and what functionality you can use. So it's always a good idea if you're not sure immediately what the problem is, you know, like I said, it could be the feature directly that you're working on, like it was with the chamfer, or it could be a prior feature that's causing a problem. The feature itself regenerated, but some subsequent child feature may fail regeneration because of something I changed in the original feature. All right. All my dialog boxes are on the other window. All right, so I'm removing everything from there. All right, so the next thing I want to go in and look at is we talked about patterning features. So I have this part here, very simple part. Actually, I'll shade this with edges so you can see the edge. Now I want to go in and pattern this feature. So this is just a simple star feature. I'm going to select on it, come in here and select pattern. Now for the pattern type, I'm going to go ahead and use directional pattern, and I'm going to create this in 2 directions. So I'm going to select it, and I'm going to go in right now. This arrow is telling me the direction. Now, when it creates the pattern and you're using the directional pattern, it goes towards the positive direction of the surface or the edge that you've selected. So that's why it's coming in this direction. So I'm going to go ahead and change this to a -9, which will now flip it to the other direction. I'm sorry, not a -9. I want that to be 15. Right. And then I want to change the number of instances to 9. Not 29, 9. That's much better. Now, I also want to go in a second direction. So I'm also going to go normal to this surface. So I'm going to click in here, there. And then once again, for this one, I am going to go in a -15. And then, there we go. And then for this one, I want to go 9 in that direction as well. This one, I actually want to change its spacing. I want to make it a little bit larger. I'm going to make it 20 as far as its spacing. All right, so there they are. There's simple cut, going through it. You can see there's a regeneration time. All right, wonderful. It goes in and creates this. Now, as I mentioned before, inside of the patterning, the default option for your pattern is a general pattern. Now, your general pattern is the most flexible. It is, with the general pattern, it will allow you to go in and create instances that go off of the model. Oh, crap. I meant to change the overall. Sorry. There we go. You can create instances that actually fall off the model, so they're not completely encapsulated in the actual geometry. It also will allow you to create instances that are on different surfaces. So this is actually an angled surface. So it still will allow it to go in and create those that intersect that angled surface as well. And the other thing that it will allow to happen is that will also, I'm actually going to reduce this number. That way we don't regenerate all 20 of these. So I'm going to take this back, take this down to 5, just so I can prove the point of this one. So right now this is showing 6. I'm going to increase the overall size of these to 12. And what that does, it now intersects each other. Now, once again, a general pattern is the most flexible pattern that you have. It can vary in size, so as I'm going in and patterning them, I can also go in and reduce the size of them as they're patterning as well. So I can use that radius I just modified and actually reduce its size as it's going in and patterning. They can intersect each other and they can lie on different surfaces. So if I go back into this pattern and edit definition, underneath options, there are different pattern options. I have the option of variable, and I also have the option of identical. If I go in and select variable and select this, this actually fails. Now, the reason that a variable pattern fails is because with a variable pattern, it can do everything that a general pattern can do, except it cannot intersect itself. So if I come in and edit definition, I'm gonna go in and change the spacing. Which direction? Actually, sorry. Actually, want to go into this. Edit that and change that back down to 6. And now it can go in and create it. So as I mentioned, it can go in and do everything except for intersect itself. If I go into the pattern again, and now I change this to an identical pattern, it works fine as well. Now, the differences between them is regeneration. So as I said, with a general pattern, each instance is actually regenerated. So because of the ability for it to intersect itself, the ability for it to fall off of the model, the ability for it to be on different surfaces, it takes longer to regenerate because it's calculating each one of those things. With a variable pattern, it's just a little bit faster, only because if it finds that it has intersecting geometry, it immediately stops. Otherwise, it still calculates everything else. With an identical pattern, everything about it has to be identical, which means when I create this pattern, it has to lie on the same surface. They all have to be the same size, which means I can't increase or decrease the size of them as they are patterning across. And once again, they cannot overlap each other as well. So if I come over now and I edit this pattern and I go in and make now this 10, it immediately fails because one of the instances of this, which is what it's not showing, will go in and actually fall off the model. If I change this to 9, it's happy. But if I change this value to actual 10 and it now begins to overlap onto a secondary surface, it will now go in and fail. So if I come over here and change this to 10, and once again, I have my regeneration failure. If I come over and now change this pattern to anything other than identical, such as a variable pattern, it's happy. So when you have those patterns that lie on a single surface and they're not intersecting any other geometry, it's perfectly fine. And once again, for regeneration speed, to go in and do an identical pattern, because literally it's regenerating the first one and just placing the other ones. So it's not regenerating them individually because it's looking for them all to be exactly the same. So it's not trying to go in and regenerate individuals. Once it finds something that breaks that individuality, that's when it goes in and now fails, or I should say commonness, and it becomes an individual. That's when it goes in and fails regeneration. Now, for this, it's not only when you're going in and going from a surface here, it also does the same thing. This pattern actually starts on this surface. So if I go in and do an edit definition, it starts here and goes through everything. But I want to do the same thing with this. I want to go in and pattern this. All the rules are the same. For this one, I'm going to, same thing, directional pattern. And for this direction, I'm going to go into a -9 again. I'm sorry, -10. And then I want to go 15 total. And then for the second direction, I'm going to go from this side again. And now this one is going to be, oh, sorry, I messed the numbers up. That's 9. This is 15. This is minus 9. And then this is also 15. And that one should actually be 10. There we go. All right. So same thing here. All the same values are the same. It goes in and patterns it. As you can see, it does take a little bit of time for it to regenerate because it is regenerating each one of them individually. And when it does this, this is where we're going to go in and see, because this is a general pattern, it's going to give us all kinds of geometry that we really don't want. Reason? Because, come on, it's pushing. Because it's regenerating each one of them separately. And what we will see is that these things actually overlap each other pretty bad. But once again, because this is a general pattern, it is allowed. If I had gone in and done this, so I'm going to do this backward. Sorry, not backwards. I'm going to delete this pattern. And if I come over here and select pattern again and start with it being an identical pattern, and the same thing, I'm going to do my directional pattern, go this direction, going up, I'm going to do minus 15. And then for the number of instances, I'm going to do 10. And then for the second direction, I'm going to use this side surface here. Same thing, minus 15. This one is going to be 9 in that direction. This is identical pattern. See how quick that was? Because it's simply going in and regenerating the first one and placing the remainder of them. And because it does not fall off of that surface, even that it's extruding all the way through, it still regenerates just fine. So if I come over and now increase the number of instances from 9 to 12, it immediately fails. Why? Because although the surface is a single surface, even though it's going through all, this surface and that surface are still different surfaces. So it now gives us an error when we're going in and regenerating that. If I change this once again to a variable pattern, it's happy, it regenerates, and everything is okay. All right, so those are the different instances for patterning. Just realized I'm running a little bit longer. I want to go in and show some relations. So in the engine block, I've gone in and created some relations inside of here based on my design intent as I was thinking of them. So I created some relations, those relations. So there's this taper geometry here, and I'm saying that this taper geometry is going to be equal to this diameter, once again, because they're proportional to each other, this inner diameter, but it's going to be that inner diameter minus 2. So now I'm designing some more, and then I'm going in and defining these fins. These fins I want to be with respect to this overall extrude, so not the taper, but the extrude above the taper, and I want that to be that extrude divided by 2. That will go in to determine my number of fins. Now I also want to go through and make sure that my ID is actually equal to the overall OD minus 3. By saying minus 3, that gives me a 1.5 wall thickness for that. And then I also want this extrude, that height, to be a ratio with this taper geometry plus 1. So whatever the length is of this taper geometry, I want it to drive what the overall extrude is. Once again, these are things, designs that we talked about to make sure everything stays within proportion to each other. Wonderful, great. Now, if I look at the number of fins, currently there's a number of 13 fins. The overall numbers, so this is 26, this is 27, so it's going to be one taller than the taper. The ID is currently 28, and then the overall OD of this is currently 31. Now, based on that relationship, when I come over, and I select on my OD, I go in and select it, I can't modify it. Why? Because it's driven by a relation. There it is. It's driven by this relation that says the ID is driven by the OD minus 3. Okay, but the same thing happens when I go in and try to change the number of fins. If I go in and try to modify them, it tells me the fins are the extrude divided by 2. The extrude tells me that it is driven by the taper plus 1. So all these things are all tied to each other. Now, the overall driving factor is this OD. So if I change this OD to 32, great, regenerate, it goes and it updates. Now with this one, it goes and updates that, everything is good. And I actually think I saw it update this at the last second as well. So when I go in and change that back to 31, there we have it. This is still at 14, although this is at 27. Now it will go in and truncate this. So this is currently 14. It should actually be 13, which is what it shows now. So this is one of those where, because of the way we've created these items, this is now 28. Darn it, it regenerated it again. So that now shows 14. But if you're noticing, it is having to regenerate this model twice in order to go through an update, basically the last part of it, which is the number of fins, because of the order that I've gone in and created everything. So I'm saying taper is equal to ID, then I'm saying fins is equal to extrude, and then down here I'm setting ID equal to OD. And then also down here I'm setting what the extrude is equal to, which is controlling the number of fins. So what needs to happen is we need to go through and change the order of this. I can cut and paste it, try to figure it out myself, but inside of the relations area, there is the option of, where to go, right there, sort relations. What it does is it searches for any value on the left side and see if it's available on the right side. If it is, it will change the order of it so that it gets solved for before something is equal to it. So for example, we are setting fins equal to extrude, but down here we're setting extrude equal to taper. So this actually needs to happen before fins does. So if I come over here and do a sort, we can see that it goes in and changes the order. So ID is good there. Now extrude is set equal to taper. Fins is equal now to extrude is equal. Taper is being solved for before extrude is being set equal to it. So as I said, we can go in and write relations as we're designing the model. And sometimes those may get our regeneration out of sync. An easy way to go through and evaluate that is using sort relations to go through and define what those things are. All right. One other thing with this one is I want to go in and also look at circular references. So I'm going to come over here and open up an engine assembly. And circular references are actually really easy to go in and create, just like what I just showed. Relational regeneration issues are also easy to create. So for example, we have our models here. I'm going to go into my analysis feature, and then we have global interference. So I can go in and run an interference check. Where to put it? Global interference. Where's my dialog box? It's hiding way over here. Sorry. So there's my global interference box. I can go and do a preview. And when it goes and it calculates, it doesn't find anything. Now understand that global interference is simply looking for overlapping. It's not going and evaluating surface to surface. We can actually do that by doing an actual global clearance. with the global clearance, it will go through and evaluate anything that basically doesn't have any clearances between them. I can do a preview here, and it will go through and show me all the items that are basically surface to surface. A lot of times, geometry-wise, we can see it because it does show those surfaces kind of blended together. So they are actually 0 to 0 as far as surface to surface. Now, for this example here, I'm just going to go into this part. Now, what I really want to do is I want the clearance of this hole to, I'm sorry, the size of this hole to be a clearance around this shaft. So I'm going to go in and activate this part. Everything else turns gray. I'm going to go into that extrude and do my edit definition on there. Now I'm going to go into the sketch itself. And currently this geometry is driven by 12. Now I can go in and write a relation that says this is equal to this diameter, you know, plus whatever, but I actually want to drive it directly by those values. So I'm going to go ahead and increase this a little bit just to get it off of there. And then I'm actually going to go in and redimension it. So I'm going to dimension this to there, and it goes in and gives me that clearance value. I'm going to go ahead and delete this 12 dimension. It brings up this dialog box. So I have too many items. I'm going to get rid of the 12.5 and leave the 0.25 for the clearance. And then I actually want that to be 0.125. So great. That way, when it's rotating, we don't have, you know, the grinding of the metal for each other. Great, great, great. Wonderful. Now I'll go back into the top level, and then I'll come over and regenerate that. And as soon as I do that, I get this notification. This notification lets me know that I have a circular reference. Why do I have a circular reference? Because what I just did was I went in and created, sorry, not a reference to there. I need a reference to there. What I just went in and did was I created a reference from this crankshaft to this engine block when the crankshaft is actually assembled with respect to the engine block. So the way this crankshaft is assembled, it's assembled using the hole in the engine block as a reference, but then at the same time, this extrude that I just created also references the surface of the shaft. So what I just did was say assemble this with respect to the hole, and then I said, okay, now drive the hole that the shaft is referencing by the shaft itself. So I just created a simple little loop that went in and created that geometry. So if I go into, sorry, I'm creating, it should be my CRC file. Yep. Inside of here, it goes and it shows me that reference loop. So I opened up in my working directory, it created this CRC file, and it says, once again, the engine references the extrude in the engine block, but once again, it also references the extrude from the engine. So this feature 42 references this feature ID 3725, which references back to feature ID 42. Now, if you want to know what those numbers mean, in your model tree, we can go in and add additional columns. In our columns, we can go through and add feature IDs, and we can even add feature numbers. And with that, it will go through and show you what those values are. So each one of these, if I go into here, once again, go back into Notepad again. If I come into here and I'm looking in the engine, and I can look for where to go, feature ID 42, which is where should be the, oh, it's at the bottom, should be this. So it's actually not linking those up properly. Oh, in the crankshaft, feature number 6. So it's looking here and it's referencing this extrude. So feature number 6 is what it's going in and referencing between the two. So it allows you to go through and kind of track down what the references are. This isn't showing all the information that I need. There it is. Yep. So feature ID, it's not showing feature ID 42. It's just showing crankshaft itself, but it's showing that it is feature number 6 and feature number 45. So this feature here, 45 in the engine, is referencing feature number 6 in the crankshaft, which is referencing feature number 45 or 45 in the engine. So we can go through and see that. And like I said, it's very, very easy to go through and create these references. Because once again, what we're trying to do is capture our design intent. And sometimes we don't think about the reciprocal effects of going in and referencing one feature to another. As I said before, we can go through and create some controls that will allow us to go through and control whether or not we can reference features outside of our existing model that we're working on. So we can do a reference control inside of there as well. All right, we are now at the hour point, so I will go ahead and at this point ask if there are any questions. If you do have questions inside of the webinar dialog box, please feel free to type them inside of there and I will answer them as they come in. All right, it appears that at this point there aren't any questions, but if something is to comes up, you can always reach me. Once again, Michael Wimberly at mwimberly at boundarysys.com. If you are interested in Windchill 12 training, it is available, and also Creo 8 has just come out as well. So look for a webinar on that coming up very soon as well to show you the new functionality inside of Creo 8. So that will be something that we will be showing within the next couple of weeks. But definitely visit our website, boundarysys.com, to go in and view that information. But if you're looking for training, update training, any specialized training, feel free to contact us. Because there are still some COVID restrictions, but a lot of those are kind of starting to back off. We can still do virtual training. We can do in-center training at any of our training centers, or we can come on site and do any training. So any of those things are available to you as well. And as I said, if you have any direct questions, you can visit our website at support.trainingptc.com. That will take you to our training location. But also just go directly to our website, and inside of our website, you will find information on training, webinars, all that information as well. If you do have any technical questions, you can reach me at mwimberly at boundarysys.com. Any sales questions, sales at boundarysys.com. And once again, our website and our YouTube channel. I truly thank you for your time, and I hope you have a great rest of the afternoon. What is this question? When I switch simplified reps, the model regens in a different position. What do you mean it regens in a different position as far as the regen number? Or because with a simplified rep, are you turning off components? So it may go through and regenerate based on the components that are no longer there. Is that the question? Is that what you're running into? Okay. Do me a favor so you don't have to stay on here. Definitely send me an email. Um, and if we want to get on a web meeting, we can do that as well to review this. Um, or just if you want to give me more description in an email, I can research it as well. Either one, and we can go through and address this. So definitely, if you want to send me an email, we can go in and address this issue, like I said, offline in more detail. Okay. Thank you very much. All right, everybody. Once again, have a great remainder of the afternoon and week.